temperature, you pump out the air.
Right, block all the light.
Exactly. Shield it from radiation, and you're just left with a perfect, silent void. A totally blank canvas.
Yeah, that's the classical view of nothingness. Basically a completely passive stage just, waiting for actors to arrive.
But when you actually step into the framework of modern physics, and I mean specifically quantum field theory and general relativity here, that empty room is anything but empty. The vacuum is, well, it's boiling. Space itself is bending.
It's incredibly dynamic.
It is. So the question we are tackling today is whether this incredibly complex fundamental architecture points to purely physical necessity or if it leaves room for metaphysical causation and divine omnipresence. Now, I argue that the universe is a beautifully self-contained, completely physical system, from gravity basically being just the geometric curvature of space-time down to the quantum fluctuations that actually birthed the cosmos. Scientific laws entirely explain our reality. We really don't need to invoke a first mover to make the math work.
Right, and I argue that the physical mechanics of the universe actually do not exclude a metaphysical cause. In fact, I think they illuminate it. The way gravity holds the cosmos together, it closely mirrors classical descriptions of divine omnipresence. And the deeper we go, especially into the holographic, information-based nature of quantum entanglement, the more that underlying architecture looks like it possesses fundamental purpose and, well, design.
Okay, let's anchor this in the most ubiquitous phenomenon we all experience, which is gravity. Historically, Isaac Newton was actually deeply disturbed by his own theory.
Oh, absolutely. The whole action at distance problem.
Yes, he couldn't physically explain how the sun could possibly pull on the Earth across 93 million miles of empty space. So he ultimately had to attribute that invisible influence to the divine.
Well, because without a mechanical link, there had to be an omnipresent sustainer holding the system together.
Right, exactly. But then Albert Einstein completely dismantled that theological necessity with general relativity. He showed that gravity isn't this mystical force acting across a void at all. It's geometry.
Just the bending of space.
Exactly. Think of space-time as a flexible grid and mass as a heavy object warping that grid. The smaller objects aren't being pulled by some mysterious force. They are simply following the natural, invisible curves of that warped fabric. So when you hold a pen in your hand, it's not being pulled down by an invisible tether.
Right.
The mass of the Earth is curving space-time, and the atomic bonds of the floor are literally, physically pushing you and the pen upward against that curvature. The mechanism is entirely self-contained within physical geometry.
The mechanics of general relativity they are undeniably elegant. Mass tells space-time how to curve, and space-time tells mass how to move. But let's look at the philosophical implications of that geometry.
Okay.
Classical theology describes the divine as invisible, omnipresent, and the active sustainer of cosmic order. If you look at an ancient text like Colossians 1:17, where it says, "He is before all things, and in him all things hold together." That is a remarkably precise functional description of the gravitational interaction you just described.
You think so?
I do. This beautiful interplay where we, live, move, and have our being within the geometry of space-time, what we might even call the Einsteinian sublime, it's structurally analogous to divine immanence. God is often conceptualized as the ground of being, and gravity acts as the physical manifestation of that ground.
I see why you think that. But let me give you a different perspective. Comparing a deity to gravity, it commits a fundamental category error. Gravity is a physical interaction that is precisely described by a 10-valued metric tensor.
Right. The math is precise.
Very precise. It dictates how energy and momentum warp the metric of space and time. It is utterly impersonal and mathematically rigid.
But wait, why does impersonal necessarily mean devoid of divinity?
Well, because it removes the ethical and relational dimensions that are central to theology. I mean, a metric tensor doesn't care about justice. A murderer jumping off a bridge and a martyr being pushed off that same bridge, they both accelerate at exactly 9.8 meters per second squared.
Yes, they do.
And when two black holes collide, they ripple the fabric of space-time so violently that they obliterate any planetary systems caught in the crossfire.
So if gravity is the literal force of the divine, or even just its direct physical analog, then that divine presence is completely indifferent to suffering. It is just math, blindly executing itself.
I come at it from a different way. That critique assumes divine action must constantly intervene to prove it is moral. But most sophisticated metaphysics, they deliberately separate natural law from active divine intervention.
To protect the idea of a good creator?
Precisely, to preserve the integrity of creation. Think about it. Gravity's unwavering consistency, its indifference as you call it, is actually what establishes the reliable physical theater necessary for free will.
How so?
Well, if the metric tensor paused or, altered itself every time someone was about to get hurt, we would live in unpredictable chaos. There would be no consistent laws of nature, and therefore no ability for rational agents to make meaningful choices. The fact that the universe operates on these universally binding, mathematically elegant principles, it isn't a strike against a creator. It's literally the prerequisite for a meaningful existence.
Okay, so if we assume this incredibly consistent physical theater, what happens when we strip the actors off the stage? If we take away the stars, the planets, the radiation, if we empty the universe completely?
Well, in classical physics, you just have a void, an empty box. And philosophically, that empty box requires an external entity to place something inside it. I mean, if you trace the expansion of the universe backward in time, you hit the Big Bang, a singular state of infinite density.
Exactly.
Exactly. A definitive beginning.
And logically, a definitive beginning demands a cause that exists outside of time and space to spark it into motion.
But that is exactly where modern physics upends the classical intuition. Quantum field theory proves that absolute emptiness is physically impossible. The vacuum is an empty box waiting to be filled.
Right, it's the quantum fields.
Yes, it is a vibrating foam of quantum fields. Even in a perfect vacuum at absolute zero, there's a baseline non-zero energy state.
You're talking about virtual particles, I assume.
Yeah, exactly. And we can literally measure this with the Casimir effect. If you place two uncharged, perfectly conductive metal plates incredibly close together in a vacuum, the quantum fluctuations in the empty space between them are restricted.
While the outside fluctuations push them together. Right. The limitless fluctuations outside push inward, forcing the plates together. The emptiness is actually exerting a physical force. It is continuously producing virtual particles popping in and out of existence.
That's fascinating. But how does a fluctuating vacuum solve the problem of the Big Bang's singular beginning?
Because the Big Bang doesn't actually have to be a singular beginning that requires some metaphysical spark. They're entirely self-contained mathematical models. Take eternal inflation, for example.
Right, where inflation never stops.
Exactly. It posits that the underlying quantum vacuum is expanding exponentially forever. And within this infinitely inflating space, localized patches occasionally slow down and release their energy, creating individual bubble universes, like ours.
So we're just one bubble.
Yes, our Big Bang is just one bubble in an infinite, eternal fractal of universes. Or consider the mirror universe model proposed by physicists like Neil Turk.
Oh, the CPT symmetry model?
You got it, CPT symmetry, charge, parity, and time. It's a foundational principle in physics that the fundamental laws of nature behave the exact same way if you flip the charges of particles, mirror their spatial coordinates, and run time backward.
Right.
Turk's model applies this to the cosmos itself. It suggests the Big Bang wasn't a beginning out of nothing, but rather a transition point. If you extend analytically back through the singularity, there is a mirror universe where time runs in the opposite direction and antimatter dominates. The mathematics perfectly balance out to zero, so there's no beginning, no first mover, just a fundamentally balanced equation that exists out of physical necessity.
I mean, that is a mathematically beautiful model, but it really pushes the goalposts. You're explaining the intricate mechanics of these fields, but kind of glossing over their actual origin.
How am I glossing over it?
Well, you say the vacuum is seething with potential, governed by CPT symmetry or eternal inflation. But where do the gauge symmetries governing those fields come from? Why does a universe obey the mathematical rules of quantum field theory in the first place?
You're essentially treating the quantum fields as if they are self-explanatory.
Because mathematically they might be.
But philosophically, they represent pure potentiality. In various metaphysical traditions, there's this concept of divine speech. Like in the Islamic tradition, it's kun fayakun, be and it is.
Right, the idea of spoken creation.
Exactly. It's the idea that existence is called into being from a pre-existing field of infinite potential. When a quantum fluctuation excites the electron field and a physical particle materializes, it isn't coming from nothing. It's emerging from a foundational, sustaining layer of reality. The structure of quantum field theory is actually a striking parallel to this idea of continuous, sustained creation. The field itself is the metaphysical ground.
It's a poetic parallel, sure, but scientifically invoking a metaphysical layer is redundant. Occam's razor favors the simplest explanation that successfully accounts for the data.
But is it actually simpler?
Yes, because if the underlying fields and their governing symmetries simply exist as fundamental, non-contingent features of reality, adding a conscious architect doesn't give us any new predictive power. The equations dictate that absolute nothingness is unstable. The universe exists because true nothingness is mathematically impossible. We really don't need to add a speaker to the void when the void itself naturally generates reality.
Well, if we are going to rely on what the math dictates, we need to look at what the math is actually revealing about the structure of space itself. We aren't just talking about particles popping in and out of existence here. We're talking about how they communicate and how space itself is actually built from information.
Ah, you're steering us toward quantum entanglement.
I am. Exactly. When two particles become entangled, their quantum states are perfectly correlated. If you measure the spin of one, you instantaneously know the spin of the other.
Even if they are light years apart?
Yes, it entirely defies the classical idea of space as a barrier. And modern physics is increasingly suggesting that space isn't just filled with entangled particles. Space itself is constructed out of entanglement.
Yes, and this is where we get into some of the most cutting-edge theoretical physics, like the ADS-CFT correspondence. It's a mathematical framework that basically links a theory of gravity in a volume of space, the bulk, to a quantum field theory operating entirely on the boundary of that space.
The holographic principle.
Right. To put it simply, the entire three-dimensional reality we experience, gravity, space, time, it might actually be a holographic projection emerging from a two-dimensional boundary of entangled quantum data. It fundamentally shifts our understanding of reality. Space and time aren't fundamental. They are emergent properties of quantum information.
Which is exactly my point. If the universe is fundamentally an informational structure, we have to grapple with the implications of the word information.
I feel like we might have different definitions of that word.
Well, the physicist John Wheeler famously proposed the it-from-bit participatory universe. He argued that the physical world derives its existence entirely from binary yes or no registrations of information. A quantum system doesn't have a definite state until it interacts with something that registers it. Information fundamentally implies meaning. It implies a self-referential architecture.
Okay, I have to stop you there, because the leap from quantum information to meaning or purpose is where the physics gets hijacked. In physics, information isn't a conscious message. It's simply the distinct state of a physical system.
But look at how that system behaves. Physicists have discovered that the mathematics governing the holographic universe are functionally identical to quantum error correction codes.
Yes, they do look very similar.
Right? When quantum computers process data, they are highly susceptible to noise, so we write error-correcting codes to protect the information. The universe appears to be doing the exact same thing natively. It acts as a self-correcting holographic information system. If the universe is constantly correcting its own underlying code to preserve coherence and prevent logical contradictions, that is a hallmark of design. It strongly suggests the cosmos is inherently biased toward preserving its own intelligibility.
It only looks like a hallmark of design if you anthropomorphize the mathematics. Quantum error correction in the universe isn't a software program written by a cosmic developer. It's an inevitable result of unitarity.
The conservation of quantum data.
Exactly. It's the fundamental law in quantum mechanics that quantum information can never be destroyed.
Even inside a black hole?
Yes, even there. Even if a star collapses into a black hole, the quantum data of that star isn't lost. It's scrambled and preserved on the event horizon. The universe self-corrects not because it has a purpose, but because the math physically forbids the deletion of data.
But doesn't that imply...
Think about how a crystal lattice forms in a mineral. It builds these stunningly precise, mathematically perfect geometrical structures, not because there is an architect meticulously placing each atom, but because the atoms are blindly settling into the lowest possible energy state. Emerging complexity just doesn't require intentionality. The conservation of quantum information is just a structural rule of the system, like the conservation of energy.
That's a compelling argument, but have you considered the existence of the rules themselves? I understand the appeal of the crystal analogy, that complex order can arise from blind rules seeking a low-energy state. But there is a major initiative in physics right now called the Conformal Bootstrap Program.
Right. Testing fundamental consistency.
Exactly. It's testing the radical idea that the laws of the universe are uniquely determined simply by the requirement that they don't logically contradict themselves. The math has to be exactly what it is, or reality entirely breaks down.
And doesn't that support my side? Absolute physical necessity over design?
I argue it supports profound design. The fact that the ultimate requirements of reality, mathematical consistency, happens to yield a universe that allows for stable carbon atoms, complex chemistry, and ultimately conscious observers who can actually decipher the quantum error correction codes, that is astounding. We aren't just crystals settling into an energy state. The universe spent 13.8 billion years organizing stardust into biological structures capable of looking back at the equations. That deeply intertwined relationship between the physical laws and the emergence of observing minds suggests the architecture of reality isn't blind at all. It is inherently participatory.
You know, taking a step back from the intense mechanics of ADS-CFT and quantum error correction, when you really sit with these concepts, regardless of the conclusion you draw, it fundamentally changes how you view existence.
It really does.
Me stripping reality down to its absolute core and realizing that everything, the solid chair I'm sitting in, the planet orbiting the sun, our own bodies, is just a temporary configuration of vibrating quantum fields. It fills me with a profound sense of awe.
It is incredibly humbling. I completely agree.
It is. And for me, that humility comes from accepting the vast, impersonal nature of it all. We exist in an eternal fractal universe, an endlessly self-correcting structural network of quantum information, simply because physical laws demand it.
Right.
We aren't the center of a grand metaphysical narrative. We are brief, brilliant mathematical inevitabilities. There is a stark, quiet beauty in realizing that the universe doesn't need a creator to function perfectly.
The scale and the strangeness of reality absolutely demand intellectual humility. But, I find that very same awe drives me to the exact opposite conclusion. When I look at the nothingness of the quantum vacuum, I don't see a blind mechanism. I see a dynamic, continuously sustaining presence.
You see the ground of being.
Yes. When I look at quantum entanglement and the holographic principle, I see a universe where no particle, no field, and no observer exists in isolation. Everything arises in deep, absolute dependence on everything else. To me, that profoundly interwoven relational fabric of reality isn't just cold math. It is a rigorous, physical symbol of a sustaining, omnipresent divine architecture.
Well, if there's a common ground we've reached today, it's that the classical, intuitive view of reality is dead. The idea of solid matter sitting statically in a completely empty void just doesn't survive contact with modern physics.
No, it doesn't. The universe is vastly stranger, entirely relational, and fundamentally built on invisible fields and entangled information.
Which means the intersection of physics and metaphysics remains one of the most compelling frontiers of human thought.
Oh, absolutely. There is an immense amount left to explore in these models, and how we interpret them matters deeply.
We definitely encourage everyone listening to dive into the source material on general relativity, quantum field theory, and the philosophy of science we've debated today. And the next time you look into what seems like an empty room, remember, it isn't empty at all. It's a vibrating, entangled ocean of potential actively holding reality together.